Right? Here's another transformation for you. F of x equals x squared. For the first one, and then second one's going to be minus x squared. X squared and minus x squared. So let me go back to the overhead here. Put back x squared in. Okay, got x squared, got minus x squared, second one. Okay, so watch it closely. There's x squared. Whoop. Didn't like my input there. Okay, there we go. All right. Here's x squared, of course. Here's the x and y axis. A little harder to see there. And here's the minus x squared. How does that compare to the x squared? Did it shift it? Not really shifting it, is it? It didn't move it right or left. It actually did this sort of thing, didn't it? It flipped it over. It took the x squared graph and basically flipped it over the x-axis. So now it's an upside down parabola. That's what we're going to call it later. But so that was because of the minus. It took the x squared and flipped it over the x-axis. So the transformation here is, we say it's a reflection. And reflections usually happen, for us anyway, they'll happen on an axis. This is a reflection through the x-axis. And that's what a minus in front will do to a function. Put a minus in front of the operation, it's going to reflect it or flip it over your axis. Okay? All right, well, same thing will happen. Let's compare that one then to this one. Back to the absolute value. The absolute value of x, then I do a minus absolute value of x. We can just do that one on our own here. All right. So I've got the absolute value of x. I've got minus the absolute value of x. So here's the absolute value of x. Minus the absolute value of x. What's going to happen? It'll flip it over. So the v, right side up v, starts out. Now what happens? Flips it over, right? Flips it over to a same thing. All right, so it flips it over, makes it a upside down v. I guess the best way to say that, right? So the same thing happens. And of course, the points here, 0, 0, 1, 1, negative 1, 1, 2, 2, negative 2, 2. Those are all now their negative counterparts, right? At positive 1, I'm now at negative 1. At positive 2, I'm now at negative 2. Negative 1, negative 1, negative 2, negative 2. So instead of the positive y values, now I've got the negative y values. So same thing. Let's talk about the x cubed graph here. Everybody okay on that one? Okay. Because there is a little bit slight difference, maybe. I mean, it does the same thing, but a slightly different thing does go on here. Because on the x cubed graph, here's what we're looking at, right? X cubed kind of the little curved thing right there. So what is minus x cubed going to do? Well, we know it's going to reflect it through the x-axis. But here's what happens different on this one. You see here, on the other ones it just flipped over. But on this one, do you see what's got to happen here? If I'm going to reflect this through the x-axis, I've got to reflect this part. It's reflected through the x-axis. But what is this part going to do? It's going to flip up. This part is going to reflect through the x-axis the other way. Because it's got to reflect through the x-axis. That's what this does. So this part is reflected down, you see, but this part is reflected up. What happens? What does that look like? Winds up looking like this. Instead of this, now we have this. See that? It just reflects it. It's like a mirror image. Think of a mirror there at the x-axis. That's what it would look like in the mirror. This part gets flipped down. Yeah. So the minus x cubed graph looks like this. So that's a little different because, on the x squared graph, it just flips down. Absolute value just flips down. This one, you've got to flip both up and down because there's already a part below here, so you've got to flip it up. Okay. All right. Now, let me also talk here while we're at it about the absolute value. Another one we talked about last time. What does the absolute value graph look like? Well, it's kind of that half shape graph like this, isn't it? Something like that. Maybe a little curvier than it should be, but yeah, because you got 0, 0, and then 1, 1. Well, that's pretty good. 4, you're at 2. That's pretty good. Okay. It was better than I thought. All right. So, what'll happen for that? Well, there's our minus on the outside again. That's going to take it and flip it over, right? It reflects it through the x-axis. And so all this now looks like what? Well, you flip it over. Looks like this, doesn't it? So instead of up on top there, we've got it reflected over. Everything's on the negative side now. Okay. So that's all good. What I wanted to show you, though, was we can talk about the other thing because notice here I put the minus on the outside. What would happen if I put it on the inside? Well, the reason I didn't mention it on, well, I'll talk about that in a second. Be aware here, that's going to do something a little different, and let me show you. Here is what it looks like on this. All right, so give my square root graph. Square root of x. All right, so there's our shape. Minus, I'll do these all separate here. Minus the square root of x. Hopefully what we expect there. Yep. All right, so there's our minus square root of x, like we said. But let me clear that out. Okay, so I'm going to put the square root of x, and then I'm going to do the square root of negative x. Here's the square root of x again. But over here is negative, square root of negative x. Do you see what the difference is? Well, the difference is it did reflect it, didn't it? Because basically, if you look at it, this one now has been flipped over here to the other side. But it didn't reflect it in the x-axis, did it? what did it reflect it in? Reflected in the y-axis. The reflection, when you have the minus on the inside, the reflection goes through the y-axis. So this is a reflection, sure enough, but it's through the y-axis instead. So just be aware of that. If the minus is on the outside, it reflects it through the x-axis. But if the minus is on the inside, in front of the x, it is going to reflect it through the y-axis. So the flipping is back to the left, or maybe if it's on this side, it reflects back to the right. But anyway, be aware of that. Okay? Let me also mention real quick here to you while I'm still got my screen up here. Let's go back to x squared. And, well, just note here on that, if I do a minus on the inside of the x squared, the reflection is through the, so here's x squared. This is going to reflect it in the y-axis, but what happens if I reflect that in the y-axis? Nothing much happens, does it? Because if I reflect that in the y-axis, this piece reflects over here, and then this piece reflects over here. I get the same graph. So that's why I didn't bring that up on the x squared, because reflecting it in the y-axis doesn't change a thing about it. So anyway, that's one thing. But really what I wanted to mention is and we'll delve into this much more next time, the next sections or two. But I did want to mention it while I'm putting things in the calculator here. All right, so x squared and 2x squared. Here's x squared. Here is 2x squared. What happens is, notice, here's the y-axis. Here is the 2x squared. All right, so this is f of x equals x squared on the outside there, and on the inner part, that's the f of x equals 2x squared. Okay? Did that shift it? No, because I didn't shift it up 2, because this point is still the same point. And I didn't reflect it. What I did was, what they say is it's a stretch. I've stretched it. I've made it, for the 2x squared, basically what that means is, for the x squared graph, is I made it narrower. This number right here made the graph narrower. Or the technical way to say it is it stretched the graph by a factor of 2. Well, the non-technical terms is it made it narrower, okay? The graph of a 2x squared graph is narrower than the x squared graph, okay? So guess what? If I do 3x squared, well, that's going to stretch it by a factor of 3. So what do you expect? Narrower than the 2x squared graph. And that's exactly what we'd see. So yeah, that number in the front so yeah, there's the 3x squared graph. You can see is a little bit inside my 2x squared graph there. A little vague, but anyway, yeah, okay? So that's the stretching. The number in the front stretches it. Now, having said that, be aware of a 1/2 x squared graph. There's x squared, and there's 1. Let me get rid of the stuff here. All right, so here's x squared, and then here is 1/2 x squared on the outside. Well, I guess technically we still say it's stretched by a factor of a half, but stretching it by a factor of half in the case of the x squared graph, what did it do there? It made it not narrower, but stretching by a factor of a half made it wider, didn't it? Okay. Now, stretched by a factor of 1/2, but in this case it made it wider. Now, what was the difference? Why does some of them, why did these two make it narrower? What's the difference between these two, you think, and then the 1/2? Well, it's a relationship between it and 1. If the factor here is greater than 1, it's narrower for the x squared graph. If the factor is less than 1, between 0 and 1, I guess we should say, it makes it wider. Okay, so I wanted to make you a note of that, especially for later on when we do some other stuff. But the number multiplied in front doesn't move it right or left, it stretches it. Okay. All right, so let's do a couple of the combination here, I guess we could call it. All right, f of x, let's graph f of x equals minus x cubed plus 6, because we can have combinations of these transformations. What do you see here happening? Well, for one thing, I've got the minus, and the other thing, I've got a plus 6. So what does this minus do? What's the transformation here? You tell me. Transformation would be minus does what? Reflects it through the x-axis. So we've got a reflection through the x-axis for the minus. And then what about the plus 6? Well, the plus 6 means what? Well, that's where you have to think, is it on the inside or the outside? And the plus 6 on this case is inside or outside? Outside, okay. Plus 6 on the outside. And so the outside is a vertical, up or down. So plus, up or down? Up, right. Okay. So it shifts it up 6. 6 units, okay. And so when we go to the graph, then that is what we should expect to see. I guess put in a couple of points here. All right. So if x is -2, now yeah, that is a good. I'm plugging in -2 for the x. That minus is kind of by itself there, separate. So be careful with that. I'm cubing -2, which is -8. But then I've got a minus of -8, so that's +8, so that's going to wind up being 14. At -2, it's going to be at 14. So watch out for those signs. At -1, well, it'll be negative of -1 will be +1, plus 6, so that's going to be 7. At 0, it gets a little easier here. 0 is plus 6 is 6. At 1, -1 cubed plus 6 is -1 plus 6 is 5. And +2, 2 cubed is 8 minus that, so it'll be -8 plus 6 will be -2. And so all that should bear out that you've got this reflection and the shift up of 6. -2 is 14. So -2 is at 14. -1, I'm at 7. 7. Okay. 0, 6, 1, 5, and 2 is -2. Yeah, there we go. Does that look right? Up 6, reflection through the x-axis? Yeah, because your x cubed graph usually looks like that. The snake is like that. Here it's the other way around. Okay? So it did come out like we thought. All right? With me on that. Is it okay? One more of those, and then we'll talk about one other aspect here. All right, so let's say we've got g of x equals 3 minus the square root, well, of x plus 4. All right, well, this one, we got a lot going on, don't we? You see here, my basic operation is the square root of x, right? Square root of x is the basic operation. Well, I've got three things really happening on this graph. What's going to be the transformation? Well, I do have the minus on the outside. So that's a reflection, isn't it? So I've got a reflection through the x-axis. And then I've got the 3 and I've got the 4. Let's talk about the plus 4. Plus 4 is on the inside. Right? Inside, that's a horizontal transformation, either right or left. Which way does plus go for that one? It goes to the left, yeah. The right or left one is the one that you might think is opposite. Plus goes to the left. Minus on the inside goes to the right. Plus on the inside goes to, so that's 4 units to the left. And last but not least, we have the 3. And I put the 3 over here because we haven't seen it appear, a number appear in front here. It's technically this is the same as, couldn't I write this the same as this? Aren't those the same? So really it's a plus 3 on the outside. That's what this means. Whether that 3 is on the side over here or that side over there. That's what it means. So it's a plus 3 on the outside, which that is 3 units. That's going to go up, right? Okay. So if I do a few points here, because of 4 units to the left thing, I would say let's move our points 4 units to the left. So instead of -2 to +2, let's go -6 to positive whatever. Okay. Couple points. -6 to -2. Just because of this. The right or left shift, that'll tell you kind of where to zero in on the x's. All right, so that'll be 3 minus the -6 plus 4. What is that going to give me? 3 minus, what will be 3 minus the square root of -2? That's what I get. Which is not a, oh, okay, yeah. That's all right. So this is not a real number, okay? That is not a real number. That's okay. I was thinking some other graph. Same thing, I'm going to get the same thing for when I do a -5. I get 3 minus the -1. The square root of -1, you punch that in your calculator, it's going to be error, not a real number, so what's going to say. All right, that's okay. These three should suffice. All right, so we've got 3 minus x is -4. So it'll be 3 minus the square root of 0, which is 3 minus 0. It's 3. 3 minus, when x is -3, it'll be 3 minus the square root of -3 plus 4. So it'll be 3 minus the square root of 1, which is 3 minus 1, which is 2. And then when x is 2, we will get 3 minus the square root of 2. Well, that's not a whole number, but it's about 3.14. Square root of 2 is. So that's about 1.6, I believe. Does that sound right? Okay. So we put that all together, and here is the graph you wind up getting. These don't give me real. These, so I got negative 4, 3. It's right there. Negative 3, 2 is right there. And then negative 2 is 1.6. Yeah, and this is where, you're thinking, here's the square root graph, hopefully, thinking that. And so I'm flipping that over, moving it left, and then raising it up 3. So that, that's what I'm thinking. That's what I've got here, isn't it? Here's where I start, and it kind of goes from there. Okay?